which separates the light into beams. We control the polarization of these beams with these polarization elements.
This green and white goes through the special light filter, or almost the high frequency, amplitude we took for the holograms. Other we just reject with the special filter.
The Gaussian, which we saw, the sinus we usually see, the most intensive one they took and
another we rejected.
And they to produce a hologram. By the way, do you know what hologram is? 3D image. And what will be advantages and disadvantages of having normal picture and hologram?
The hologram, I guess, you can see more.
Well done, 3D, you can go behind. You can see.
Disadvantage is that I guess it doesn't look as sharp as a normal image.
And what are the disadvantages? Now we have photographer here. Can we bring this equipment with us?
In some years.
Maybe.
In a few years, maybe if we compress all this, we can have holograms in our phones. When we're having video calls, maybe we can just have holograms.
Sorry, how long does it take to make a hologram? Like to just make it?
If we make a photograph, we only record only the amplitude. If we make a hologram, we record amplitude and phase. So this 3D of the image is from the phase.
Yeah, okay, but how long does it take to create it?
It depends on the power of the laser. More power, less time. Almost 2-3 seconds. No more. Yes.
This one, 2-3 seconds.
If we use 5-6 watt of power of the laser power, almost 2-3 seconds.
Can we see how it's created?
I have a question.
No.
So it depends on the material, which is a kind of emulsion like a special solution, let's say, chemical solution, a bit more viscosity, and depends on what filter you will put. Like this, you will produce the hologram. But I think he asked the size of the
Mobile, is it possible with our technology right now, can we integrate
В момента се разработва това нещо въобще на световно ниво.
Now with worldwide, while they work on this to produce such kind of technology and to be able, everyone to be able to see
На
hologram.
много малък носител, огромно количество информация оптически да се запише.
So the idea is in a very small amount of space to produce a huge to store a big amount of information. Now hologram.
Първо, въобще тези плаките ги държим в ето такива, аз няма как да я отворя в момента, тя ще се освети.
So firstly because the filter, the emulsion is placed in a special liquid, and if we now cut it and open it, it will get lighter. It will yes, you know better because of the
Първото нещо е, че изследователите преди холограми оставяме плаките тук, ние наричаме да се темперира, т.е. да приемат температурата, която е тук.
So 2-3 days before they will do the hologram, they leave the emulsion here to set the certain temperature, and after that
Всичко нагласяваме си през това време експеримента
this time they set the experiment,
и всичко правим на тъмно.
and it's very dark here. It should be dark.
Най-много 2 човека.
And only to at least up to 2 students, up to technicians, professionals. I'm sorry.
Това, което е важно, много бърз начин ние трябва да поставим плаката, след като е нагласен цел експеримент. Я поставим ето тук, сега аз съм взела голяма
This what is
плака.
very important is that after you set the experiment, very quickly you have to feel the emulsion.
Because here the temperature is almost 18 to 20 degree and our hand temperature is 37. So we have so fast to put here the plate.
Not
Yes, and the wait almost 5 minutes. It's enough. After that we turn on the laser and we have here automatic shutter. We put 2-3 seconds before that we calculate how long will be the recording of the hologram. It depends on the power of the laser.
Right, diffraction.
Oh, that's a slit. Okay.
And
can see
all
now that
these diffraction orders has their unique properties, their polarization which we want to have. So this is exactly what is used. It's
no
like the curve.
diffraction.
It's very.
Yes. The curve
Yeah.
with the maximum.
Yeah,
in
with the
middle.
maximum.
So here is the maximum.
Can I check?
This is
Can
the
you
Yeah, and then
see-
you
can
get
you see
weaker
the
here,
plus
right?
minus,
Like
Yeah.
plus
weaker,
minus.
stronger, strongest.
But there's the
Yes,
light there.
yes. It depends on the
Here is what
on the angle of these two beams. How many orders we will have? We have, for example, diffraction gratings with more diffracted orders, and if we make diffraction gratings and then rotate the sample in 90 degrees and make another diffraction gratings, we have 2D diffraction gratings with not only
on
this
the
axis
field.
but yes,
Vertical and horizontal.
vertical and horizontal.
You see that the powder is on this on the surface of the grid. What is important for us that in these holes we have, however, particles because the method is transmission. So if this is not a grid with holes, we will not see particles. So it is important to be in a hole.
But the particles are coming from the crystal, right?
No, particles are synthesized material from our colleague that I told you for an application.
Okay.
The sample which is inside that now we will gonna observe is one material already synthesized. But the electrons transmission come from the crystals down.
Okay.
The electrons fall on the screen and give this greenish light because in general our eyes don't see electrons, they are invisible for our eyes. That's why we use this screen with this greenish light to see electrons. So it means that all beam that is generated inside go through the samples, give this image of the objects, and where there is no particles, you see green light because the screen is fluorescence. by electron. So this is the principle to see.
This
I can't see.
microscope is unique for our country. We have only two microscopes of this power to see really nanomaterials. So one here and one in the Sofia University Faculty of Chemistry and Pharmacy.
So here is a crystal.
But it is very important for all colleagues that synthesize new materials.
And now from here you take the information, give them the information, and they can consider how well they fix the shape, the structure.
This is for the shape. So you see the transmission mode, you see the image of the particles by transmitted electrons. But we can go to diffraction mode. Here I will receive crystallographic information, so we can measure the interplanar differences of the lattices of the material, the crystalline materials that are in the samples.